So, our last chapter, I think that we're covering. And then we might cover a couple sections of calculus, but we'll see how that goes. I found out this year that Miss Wheeldryer no longer covers conic sections in Algebra 2. Conic sections? Have you ever heard of that? So since she doesn't cover it in Algebra 2, guess what? Falls on the calculus or the pre-calc teacher to teach conic sections. Didn't know that. So here's conic sections. What are conic sections? Parabolas, ellipses, and hyperbolas is what we're going to focus on. Okay? So we're going to focus mainly on parabolas today. All right. So let's say we have a right circular cone on top of a right circular cone, and they meet at each other's vertices. So we have an upper nap and a lower nap. Okay? We're not going to try to take a nap right now, please. Just talking about naps as far as cones go. All right. So if you take a cross section kind of diagonally through the upper cone, it makes an ellipse. If you hit the upper cone or lower cone, you could, at an angle where you only hit just this one, it makes a parabola. Or if you slice down through here, it makes two parabolas, an up parabola and a down parabola, which are called a hyperbola. Other ways of hitting cones, if you go right through the center where they meet, it'll just make a dot. Right along the edge, it'll make a line. And right through the vertex of where they hit, make two V's. But we're not going to worry about the dot, the line, the V's. We're going to worry about ellipses, parabolas, and hyperbolas this chapter. All right. So we're going to take an equation that looks like this but has numbers in it, and we're going to turn it into ellipses, parabolas, and hyperbolas. Okay? So it can be a little bit complicated at times. So a parabola is a set of all points in a plane equidistant from a particular line called the directrix line and a particular point called the focus. So the parabola is the blue. It goes through a point called the vertex. The vertex is on an axis of symmetry, and you have seen that before. Okay, you have seen that in Algebra 2. Axis of symmetry, vertex, and that. But we're going to add in what is called the directrix line. So the vertex is halfway in between the focus and the directrix line. Okay? This point, any point on the parabola, like a point out here somewhere, is the same distance away from the focus and the directrix line. Okay? So a parabola is a set of all points equidistant from both the directrix line and the focus. So it's going to wrap around the focus. Now, you have a parabola that goes up or down, which is normal for most of you. Okay, you've seen parabolas go up or down. So that's, and I don't like this equation. I change it. I change it to y equals 1 over 4p times x squared. Okay, y equals 1 over 4p times x squared, where p is a point, and it's the distance from the focus to the vertex or the vertex to the directrix line. That's this distance in here. Okay? Now, if this is positive, the parabola is going up. The focus is above the vertex. If this is negative, it's going down and the focus is below the vertex. Okay? So this equation right here is important. Okay? Now, what we're going to refine that equation into is y minus k equals 1 over 4p times x minus h squared. What's the h and k have to do with anything? That's the vertex, and so that's when the vertex isn't going to be on the origin. When the vertex is on the origin, it's pretty easy. But when the vertex isn't on the origin, then you got to do a little more math. Okay? But we all like math. That's why we're in here. We're advanced math students. We enjoy math. Well, most of us enjoy math, right, Mr. Barger? No? All right. So parabolas with a vertex of 0, 0. They have their stupid equation. My equation would be y equals 1 over 4p x squared. And then they have another one next to it and going, ooh, what's that? Well, that's x equals 1 over 4p y squared. What does that parabola look like? Well, looks like that. It's a sideways parabola. So you might have one going this way, or you might have one going this way. Sideways parabolas, okay? So their vertex is at 0, 0, but their axis of symmetry now would be the x-axis, okay? All right. So this is the x equals 1 over 4p y squared graph, okay? So if this is negative, it's this one. If it's positive, it's this one, okay? Find the equation of a parabola. Find the equation of a standard form parabola whose directrix line is x equals 3 and whose focus is at negative 3, 0. All right, so what I do is to help me understand this, I graph it out a little bit. 1, 2, 3, 1, 2, 3. So this is the focus. This is the directrix line. The vertex is going to be halfway in between. So the vertex is at 0, 0. Okay? So it's going to wrap around the focus, right? So it's going to kind of go like this and like this. Okay? P is the distance between these two. So what's that distance there? 3. And we're going in the negative direction, so P will equal a negative 3. So in my equation, the way I write it is x equals 1 over 4 times negative 3 times y squared, or x equals negative 1/12 y squared. That's the equation of that. So y squared equals negative 12x. So I don't know how they'll want you to write it on your homework. Okay, so then if our vertex isn't at 0, 0, we're going to have an h and k there. So the up and down looks like this, except for they right there is a little different than me. And the left or right looks like that. Okay? So find a standard form equation of the parabola whose vertex is at 1, 2, and its focus is at 1, negative 2. So So 1, 2 is the vertex. 1, oops, that's 2, 2. 1, 2 is the vertex. 1, negative 2 is the focus. So if this is the focus and this is the vertex, how far is it from the vertex to the focus? 4 in the negative direction, right? So actually the directrix line will be 4 above that, so it'll be way up here. And this will wrap around it like this. Now, why did I make it so wide? Well, the focus and directrix line are 8 away from each other. So if you go out this way 8, then it'll be 8 down to get to the next point. So it's way out there somewhere. But we're worried about the equation, okay? The way I write my equation, this is an up or down parabola, right? So y should be alone. So y minus the y value of the vertex. Y minus 2 equals 1 over 4p. 1 over 4 times negative 4 times x minus 1, the x value of vertex, squared. So y minus 2 equals negative 1/16 x minus 1 squared. Okay? All right. So let's look and see, discard. Let's look and see what our problems. Oh, Mr. Bearspach, you're so stupid some days. I forgot to do something. I forgot to push print. Print. PreCalc, new section 8. Boom. Okay. All right, here we go. Zoom in a little bit. Okay. So on this first one, it says x squared equals 20y. I like to write it as y equals 1/20th x squared. So it's 1 over 4p, right? Equals 1 over 20. So what would p equal? If 4p equals 20, what does p equal? 5. Now, is there x minus anything, y minus anything? Nope. So the vertex would be at 0, 0. The focus is a positive 5. So it'd be 5 above there. Okay? Because y equals x squared. So it's an up or down one. Okay? And it's going to be an up one. So for our up one, the focus is at 0, 5. The directrix line is at y equals -5. And my focal width, I don't know if that's 5 or 10. What do they say it is? 20? What is focal width? 20. So it must be 4 times this. This must be that number, I guess, focal width. Yeah, I don't know. That's nothing I really worry about too much. All right. A certain parabola has this equation. What do we notice here? The y is squared, so it must be a left-right. And since 8 is negative, it's opening to the left. Okay? Where's the vertex going to be at here? Is it going to be at 3, 2, 2, 3, -3, -2, -2, -3? What would it be? -2, -3. Because it's the opposite of this number, opposite of this number. Okay. Now, -8. So 4p would equal -8, right? So p would equal -2. So 2 to the left of the vertex should be where our focus is. 2 to the left of this. 2 to the left would give me a -4, -3. So the directrix line is 2 to the right of this, which is x equals 0. My focal width must be 8 or -8. What do they want there? Focal width is 8. So it's a positive number because it's a distance. Whoa, let's undo that, sucker. All right. Then you'll have to match a graph. This is the easiest question on here. Okay? Why is it the easiest question on here? Well, if x is squared, then it's an up-down. So these are up-downs. These two are left-rights. Okay? Now, this one is positive, so it must be going up. So x squared equals 7y is that one. This one's negative, so it must be going down. And then we have a left and then a right. Okay? All right. So you'll have questions about vertex, focus, directrix. Let's just do this one right here. Okay? If the focus is at 0, 14 and y equals -14, where's our vertex at? If our focus is at 0, 14, and our directrix line is y equals negative 14, what's halfway in between negative 14 and 14? 0. So it's going to be 0, 0. So if it's y equals negative 14, you got a parabola, and the focus is at 14, you're going to have a parabola that's going up, right? 0, 0, okay? So it's going to be a y equals 1 over 4p x squared. So y equals 1 over 4 times 14 times x squared. Now, I suppose they want their answer in their format, so x squared would equal 4 times 14, which is 56y. Okay? So that's how you do these. And so some of them are fairly similar towards the end. Let's do this one. Focus is at negative 6, 5, negative 6, 5. Directrix line is at y equals 3. So your vertex is going to be halfway in between. What's halfway in between negative 6, 5 and 3? Y equals 3. Well, it's an up-down one, right? So your x value isn't going to change. It's going to be at negative 6. What's halfway in between 5 and 3? 4. It's going to be at negative 6, 4. And we're just going 1 to get there. So in my old-fashioned way of doing it, I'd say y minus the y value equals 1 over 4 times 1 times x minus the x value. But what they do is they multiply each side by 4 to get rid of that. So 4y minus 4, x plus 6 squared. X plus 6 squared, 4 times y minus 4. So it'd be that one. Okay? So there's 11 questions that are like that. You know, once you get to number 4, most of the rest of them are very similar to each other. Kind of, you might just need a scratch paper to jot things down to kind of get things to where they need to be. But there you go. I will put it out there.